Let's try a word problem that we can solve with a system. In one day, the National Civil Rights Museum in Memphis, Tennessee, admitted 321 adults and children and collected $1,590. The price of admission is $6 for an adult and $4 for a child. How many adults and how many children were admitted to the museum that day? The first thing you'll do is define your variables. The question is asking you how many adults and how many children were admitted to the museum that day. So those should be your variables. Let's choose A to be the number of adults and C to be the number of children. Next, we'll go back and reread the problem. Since we have two variables, the number of adults and the number of children, we're going to need two equations. So here it says that the museum admitted 321 adults and children. So that means the number of adults and the number of children together had a total of 321 people admitted to the museum. The way I would write that as an equation would be the number of adults plus the number of children equals the total number of tickets sold, which is 321. So A plus C equals 321. Next, we need another equation. In this case, our other equation is going to be about price. We've got a total price of $1,590. And I know that it's $6 each for the adults and $4 each for the children. So $6 times the number of adult tickets would give me the total price of all of the adult tickets sold. And then $4 times the number of children's tickets sold would give me the total amount of money raised by selling children's tickets for the museum. And if I added the amount of money for the adults and the amount of money for the children, that would give me the overall amount that they collected for the day, which was the $1,590. So this is my system. And because I have coefficients equal to 1 in the top equation, it's probably going to be easiest to solve this system with substitution. So I'm going to take the top equation and solve it for C by subtracting A from both sides. Then I'm going to replace the C in the second equation with my new expression for C, which is 321 minus A. So now my second equation becomes 6A plus 4, but then instead of C, I know that C is equal to 321 minus A, and then copy the remainder of the equation from there. Next, I'll solve this like I usually would. I'm going to distribute and combine like terms. And then I'd need to subtract. I'm going to come over here because I'm kind of running out of space. I'm going to subtract 1,284 from both sides of the equation so I can start to get all of the variables on one side and all of the constants on the other. And then I can divide both sides by 2. And I get that A equals 153. And I can go back up to this equation to easily find C, now that I know what A is. And come up with 168. Since this is a word problem, my final answer will be kind of a sentence or a phrase. And that is that there were 153 adults and 168 children admitted to the museum that day.